Hi everyone and welcome to Chem Talk, where today we will be going over basic conversions and how to calculate molar mass, moles, and atoms. So, let's talk about it. A mole is the unit of an amount of substance and SI units for measuring large quantities of small things such as atoms or molecules. So, what is a mole of an element? A mole of any element is equivalent to 6.02 times 10 to the 23 atoms. This is known as Avogadro's number. This means that in 1 mole of bromine, we're going to have 6.02 times 10 to the 23rd atoms. And it's going to be the same thing for 1 mole of hydrogen, where we're going to have 6.02 times 10 to the 23rd atoms. Now you might be asking, what is a mole of a compound? Well, a mole of any compound is equivalent to 6.02 times 23 atoms for every atom in the equation. So if we have 1 mole of HCl, we know we have 1 mole of hydrogen, which is going to be equal to 6.02 times 10 to the 23rd, plus the 1 mole of chlorine, which is also going to be equal to 6.02 times 10 to the 23rd. So we get 12.04 times 10 to the 23rd atoms in total for the compound. Knowing that information, let's go ahead and try some quick practice. How many moles of oxygen are in H2SO4? How many atoms? And how many atoms of carbon are in sucrose? Go ahead and pause the video and try these, and then we'll come back to explain them. In H2SO4, we know that we have 4 moles of oxygen, and we know in order to get from moles to atoms, we have to use Avogadro's number. So we multiply by 6.02 times 10 to the 23rd atoms to end up with 24.08 times 10 to the 23rd atoms. Now let's move on to how many atoms of carbon in sucrose. Well, sucrose's formula is C12H22O11. This means we have 12 moles of carbon in sucrose. So in order to get from moles to atoms, we have to use Avogadro's number. So we multiply by that number to get 72.24 times 10 to the 23rd atoms. Now, I was being a little bit lazy by not putting them in scientific notation, but if you did, here are the answers for it in scientific notation. In order to be able to determine grams from a mole, we're going to have to know molar mass. The molar mass of a substance is expressed as the grams per mole of a substance. This is not to be confused with molecular weight, which is the mass of a molecule of a substance. The main difference between both of these is going to be the units that they are in. Molar mass is going to be in grams per mole, while molecular weight is going to be in AMU. Now, let's go ahead and look at 1 mole of water. What would be its molar mass? Well, it has 1 oxygen, which molar mass is going to be 16 grams per mole. It also has 2 hydrogens, whose molar mass is 1.008 grams per mole. So we're going to go ahead and multiply the hydrogen's molar mass by 2 and add them together to get the total molar mass for the mole of water. So we're going to end up with 18.02 grams per mole. Now you might be asking, what about its molecular weight? If we had 1 molecule of H2O, it's going to look the same, but its molecular weight is going to be 18.02 AMU. Now let's try some conversions. How do we know the grams in a mole, or atoms in X amount of grams? This is where conversion tables come in. Let's say we have 12.04 grams of NO2. In order to get grams to moles, we're going to need the molar mass. Nitrogen has a molar mass of 14, while oxygen has a molar mass of around 16. So we're going to go ahead and multiply oxygen's molar mass by 2, because we have 2 oxygens in NO2, add them together to get NO2's molar mass to be around 46 grams per mole. Anytime you're doing a conversion table, you always want to start with what you know. So we know that we have 12.04 grams of NO2. In order to start with what you know and get to what you want, you're going to need a couple different proportions in the middle in order to get to your final result. So what we know is NO2's molar mass, which is a proportion of the grams per mole. So in order to be able to cancel out units, we're going to go ahead and put the 46 grams of NO2 on the bottom and the 1 mole of NO2 on the top. This leads us to 12.04 divided by 46, which gives us 0.2617 moles. The only reason it ends up in moles is because the grams of NO2 both cancel when it's divided out, and we're left with moles on the top. Now let's try and get from moles to atoms, like we did before. You can also do this in a conversion table. So let's start with the 0.2617 moles of NO2, and let's use Avogadro's proportion, where we know that 1 mole of NO2 is going to be equal to 6.02 times 10 to the 23rd atoms. The mole of NO2 has to go on the bottom, so the units will cancel, and then we leave atoms on the top because that's the units we want to be left in. After doing the math, we're left with 1.576 times 10 to the 23rd atoms. So there's both 0.2617 moles and 1.576 times 10 to the 23rd atoms in 12.04 grams of NO2. I'm going to go ahead and let you guys try a practice problem. You have 3.65 moles of acetic acid. Using only the periodic table, how many atoms do you have? How many grams? Milliliters. Go ahead and pause the video and try it on your own, and then I'll come back to explain it. So we know acetic acid's formula is CH3COOH. So let's start by calculating the molar mass like we did previously. We know we have 2 carbons, which have 12 grams per mole, and we're going to multiply that by 2. We have 4 hydrogens that have around 1 gram per mole, and we're going to multiply it by 4. We have 2 oxygens that have around 16 grams per mole, multiply that by 2, add it all up, and we're going to get 60 grams per mole for the molar mass for acetic acid. So, like before, let's start with what we know. We know we have 3.65 moles of acetic acid, and we know in order to get from moles to atoms, we have to use Avogadro's number. So we put 1 mole of acetic acid on the bottom, and 6.02 times 10 to the 23rd atoms on top. After doing the math, we get 21.9 times 10 to the 23rd atoms because both mole units canceled and we left with atoms on top. Now let's try and get grams. We're still going to start with moles, so we start with 3.65 moles of acetic acid. And we know in order to get from moles to grams, we have to use the molar mass. So we go ahead and put 1 mole of acetic acid on the bottom, and on the top, we're going to put the molar mass that we just calculated, which is 60 grams. Now when you do the math, which is just multiplying 3.65 and 60, we go ahead and also see that our units cancel out to leave us with 219.1898 grams of acetic acid. Now let's try to get to milliliters. Now this was a little bit of a trick question because I didn't give you guys acetic acid's density, but density is another proportion in which we compare grams to milliliters. The density of acetic acid is 1.05 grams per milliliter. So let's apply that to the grams that we have to try and get to milliliters. So we know we have 219 grams of acetic acid, so we're going to go ahead and put that first. Now we're going to use the proportion of density to calculate the milliliters. We'll go ahead and put 1.05 grams on the bottom so we can cancel out the grams, and the 1 milliliter of acetic acid on the top because that's the units we want to end in. So once we divide 219 by 1.05, we're left with 208.75 milliliters. Now this goes for pretty much any problem. As long as you have a starting amount, you can go ahead and find proportions in any literature source that will allow you to cancel the units, so you could do pretty much any conversion. Obviously, there are some conversions that aren't possible, but for the most part, going between any amounts in chemistry, you will be able to convert from one to the other. Now that we know how to do a conversion table, let's go ahead and summarize what we learned. A mole is a unit to describe a large amount of a small object. A mole is always equal to 6.02 times 10 to the 23rd atoms. Molar mass and molecular weight are not the same. Their units differ. Conversions can be made between grams, moles, milliliters, and atoms using a conversion table. That's all for today on basic conversions. Thank you for tuning into Chem Talk. Make sure and visit our website, www.chemistrytalk.org, for hundreds more general, biochem, and organic chem articles. Also, I'm going to go ahead and link in description a tutorial to learn how to use basic conversions as well.